So I would like to start with a slide that shows evolution of the modern application. So previously, a typical application contained just three layers: a DB layer, application layer, and some web UI interface layer. But nowadays, we are moving to the cloud. We started to deploy our applications using microservices. The number of connections between your pieces of architecture, the number of microservices grew a lot. And what is more, we started to use orchestration like Docker or Kubernetes. So we see that previously a typical application was easier to monitor. But nowadays, the number of connections and things to monitor grew a lot. What is more, modern applications produce a lot of more metrics, traces, and logs. So what are the main sources of typical modern application in terms of metrics? First of all, there are microservices. So if you deploy your application on microservices, each node produces their own metrics. And you can deploy your service on several hundreds of machines. And each of these machines produce their own metrics. The second source of metrics are containers. So imagine if you redeploy your application on Docker or Kubernetes, or your container just goes up and down, it will produce a completely new set of metrics. So you send a lot of new metrics into your monitoring system. And the third source in modern applications of metrics is serverless. So imagine that with every invocation on your function in the cloud, there is another function associated. So every call in the AWS Lambda produces a new metric. So you see that modern applications ingest a lot of metrics into monitoring system. And we call it high cardinality. So what does cardinality mean? So imagine that you want to monitor a single metric called disk usage. And you deployed your service into a cloud on some microservices environment. So you deployed your cluster called Forge on 100 nodes, and you want to monitor 10 services on each node. So you see that this single disk usage metric produces 1000 unique time series into your monitoring system. It's 100 nodes times 10 services. And that's the definition of cardinality. So cardinality is the number of unique time series stored in your monitoring system. Here in this example, the tags associated with your metrics have only fixed value, 110. But it's not always that easy, because tags ingested with your metrics can potentially have infinitely many values. And this is our example from Sumo Logic. We collect metrics from AWS CloudWatch system, and they have an instance ID tag associated. So every time when you collect metrics from another node, or due to autoscaling, you produce a new metric. So your metric from AWS cluster can have a high cardinality. And what is more, imagine a misconfiguration in your system. Like with every data point, you not only report timestamp as a timestamp, but you report timestamp as a dimension. So in this situation, your cardinality can blow up. The same situation can happen if you report, for example, a thread ID with your metric. Your cardinality can grow a lot. And I would like to show you an example of high cardinality query in Sumo Logic. So basically, we use metrics and Sumo Logic to debug our own applications, so we do dogfooding. So this is an example of CPU system metric across many nodes from service called Katta. And you can see that it's very hard to see what's going on inside your service. You have a lot of unique time series, and from this graph, you don't know, for example, what's the average, and you don't know the trend. Is my cluster CPU going up, down, or it's constant? You don't know from this graph. And with the cardinality, there is a second term highly connected. It's ephemerality. Whereas cardinality was about the number of time series, ephemerality is about the volatile nature of your metrics. So this is the definition. So if one of the tags changes frequently over time, for example, container ID in the Docker world, it produces ephemeral metrics. So you can see if your container goes up and down, the ID associated with your metric changes. So this is the ephemeral nature of modern services. They are short-living, producing new metric every time when you have to redeploy your application or you push code to production. And the observation is simple. High ephemerality implies high cardinality. If you have a lot of time series from your ephemeral system, the cardinality grows up. So this is an example from Sumo Logic. This is a query for the last 60 days for a particular metric from one of the receiver nodes. And you can see this is basically the same metric, but different time series. Due to autoscaling nature, this metric produces several unique time series in the last 60 days. But in the more ephemeral environments like Docker or Kubernetes, the number of unique time series can be even higher in a one-day query. In the one-day period, these technologies can produce several unique time series. So you see that modern applications produce high cardinality metrics. Modern applications run in the cloud on microservices technologies using Docker or Kubernetes, and it's actually hard to see what's going on inside your system. The monitoring of modern applications is challenging. So what are the main challenges with monitoring of modern applications? So you have many time series matched by a single query. Your single query matches a lot of time series across your nodes, across your system running in the cloud. These queries are time consuming because you have to pre-process a lot of data. If you have a lot of data, a lot of unique time series to retrieve from your database system and then compute average on the fly, it can give a poor user experience. What is more, it's harder to navigate data because you ingested a lot of unique time series into your monitoring system. The visualizations are obscured. It's hard to see what's going on in your ephemeral environment. And what is more, your metadata collected in your monitoring system grows over time. So Sumo Logic can help you with the hard cardinality metrics. And I would like you to introduce a new feature called dimensional transformations that was released this week together with our Kubernetes solution. So what's the high-level idea of this? So you keep your low granularity metrics for recent ephemeral data in the short-term storage just for 8 days, and in the same time you pre-aggregate metrics on the ingest for larger scale overview, and you keep them in the long-term storage for 400 days. So the idea is here simple. The ephemeral metrics loses their value over time, so you don't need to keep them for a long period, whereas you are interested in the metrics from higher level overview. And you pre-aggregate them during the ingest on non-ephemeral dimensions. So let's see how it looks in details. So imagine that you have this metric disk usage from my example. You deployed it in some container, and this container is sending a container ID along with your metrics. So you see that on this graph it's hard to see what's going on. You have a lot of time series and you don't know what's the trend. So idea is here as follows. Let's create a rule that aggregate your metrics on this non-ephemeral dimensions. So let's aggregate my metrics on cluster and node, and in the same time add a special tag, meta tag, to your aggregated result to find your metrics more easily. So you can see that this aggregation can produce a simple matrix like minimum, average, maximum. And from this graph you see what's going on. you see that average is pretty stable among your metrics. And you find your metrics now more easily. You can refer to this added tag equals node level. And what is more, you get your result faster because you don't have to compute the heavy average result, for example, on the query path. And because these metrics from ephemeral containers lose their value over time, you can store them just for 8 days. So now you can compare the left and the right side of this graph. I think on the right side is much more easier to see what's going on. So transformation rules built and released together with our GA solution this week can help you with simplify your metrics queries. You can add tags to find your metrics more easily. You get your results faster because you don't have to compute the heavy computation on the query path. And short-term retention, the second part of this feature released this week, can help you with control the volume of the ingested data. You can store metrics from lower level components for 8 days or drop them completely if you are not interested in this low granularity data. But don't be afraid, we will keep your higher level aggregations for the regular period of 400 days. And together with these two features, we built a UI that can help you to set your rules. And this UI also can help you to see, give you insight what's going on inside your application. Because you have a list of all your rules defined by your administrators. So to add transformation rules, you can just need to specify a selector. It's a scope that will match your matches to aggregate. It can be basically any metric definition selector. It can be your pod level, cluster level, or just a single metrics query. Then you specify the fields you want to aggregate on. For example, metric, cluster, and node. Then you can add the transformations that are the tags that will be associated with your transformation results. And referring by these tags, you can find the aggregations more easily. And in the end, you can specify the retention, both for the input data and the aggregation results. This part of my presentation was about queries. But sometimes a single query is not enough to explore. It's not enough to see what's going on inside your system. And first of all, to run a query, you have to know what to query for. So we built a feature called Explorer, and I think it's the 5th time today that you see this screen, but sorry for this. So we built a predefined topology supporting Kubernetes. You just set up a Sumo Logic collector, and then we can fill this tree with your metrics. Thanks to this, you can explore the complex topology of Kubernetes just having this tree. For now, we support 2 types of trees, Kubernetes namespace view and Kubernetes cluster view. So inside your cluster, you see a list of nodes, and inside of nodes, you see a list of pods. And together with this topology view, we built a predefined dashboard that can help you to see what's going on in your system on high level. So now you can see, for example, the average CPU utilization among your cluster nodes, the total memory usage, and pods running inside your cluster. But if you are interested in the lower level details, if you need to do some troubleshooting, you can just by one click refer to the logs associated with these meta tags combined with your pods. So thanks to metadata, we can jump between your dashboards to the logs or metrics for lower level overview and for troubleshooting. So how many of you use metrics tab? So a few, I see. So one of the biggest pain points in our product, in our internal adoption, was autocomplete. So previously, it was hard to find the right metric because it worked only in the prefixes. But now, in this Explorer tab, we improved our autocomplete. So you can query not only for the prefix of your dimension, but the part of the dimension. So now, for example, if you want to look for a metric called loading time, now you can find your right metrics. So let me back to the original slide with challenges with monitoring. So many time series matched by a single query is no longer the problem because we have these transformation rules and we have these aggregations, pre-aggregations on the ingest level. Time-consuming queries, the same. We pre-aggregate your data during the ingest so you don't waste your time on the query path. It's no longer too hard to navigate data. We built an Explorer to give you a holistic overview of your system. And we have a predefined dashboard to see what's going on. We improved the visualizations in the new Mu boards. And the last part, we stopped the growth of your metadata thanks to short-term retention. For recent ephemeral data from your pieces of architecture, you can store them just for 8 days. So the 3 takeaways from these presentations. Monitoring of modern application is hard, but thanks to Sumo Logic, you can first of all aggregate and monitor your high cardinality metrics. Secondly, you can control the volume of the ingested data. And finally, you can explore the complex topology of your system. Thank you.
If you have any questions, feel free to ask.
Yeah, so I like this because I actually pre-aggregate a lot of metrics going into Sumo already, in order to solve this problem. But I'm curious, how does, having the 2 different retention periods and stuff, how does that interact with billing, such that would there be billing consequences, say, to now suddenly shoving in 100,000 metrics instead of pre-aggregating them and letting you do it?
So basically we bill still for the data points per minute in receiver. And as far as I remember, we have, I don't know the exact details, but I think you don't bill extra for this transformations metrics. We bill for data points per minute seen by receiver.
So with Prometheus, one of the things that has always made that difficult exporting out to other people is because Prometheus by default what you turn on a cluster, you have 200,000 metrics that are all shipping out, and a lot of them are noise. And one of the things we're in the closed beta on that, and I really like that you guys kind of provide a pre-cut down set of metrics that you're going to build the dashboards off of and stuff. But it's always felt odd at odds to me because the reason Prometheus can do that is because it's so storage efficient and because it's so compute efficient, but then that doesn't ever seem to translate to vendors who are taking Prometheus metrics yeah, this is easier and better to store, but we're still going to charge by data points per minute when we're in a world now where you can just easily send and analyze 400,000 high cardinality metrics. So on the back end with the new product, are you guys storing that in a Prometheus native way? Is that making it easier for you guys to take in high cardinality metrics? Because the pricing is overall much lower than the other vendors who are Datadog and stuff who are taking that. How are you approaching that?
So we built our own storage for time series. And to answer your question about this highly cardinality sources, so for now we have only a blacklisting mechanism that prevents you from some misconfiguration. So basically you can send us 100,000 of unique time series per week. And if you want more, you can reach the customer success, and we will happy to understand your use case. Is this 100K metrics per week enough for you?
Okay, thanks.
Any more questions?
So for this pre-aggregation, usually by 1 minute or 5 minutes, or you can control, or just always fixed it.
So we use, for these aggregations, we use 1 hour rollups, and one for longer period, and 1 minute for last 7 days. We don't store raw data. We have, for last week, we have 1 minute aggregates and normally 1 hour aggregates.
Any more questions? Okay. Thank you so much, Michal.
Thank you.